that actually
This will be way too easy.
I'm not screen
Alright, I forgot my tripod
I
today.
was screen sharing.
1, 2, 3, 4, 5, 6, 7 people rocked up. None of you were supposed to be here. And as punishment, I'm going to move on to the next topic. Right?
I forgot my book.
So, if you go, well, who cares? Did you forget your brain?
Yes.
Yes.
Point charge.
Yeah.
Let's call it a negative charge.
I read
Right.
that this morning.
3 millicoulomb negative charge. It's going to emanate an electric field. So you've got your lines leaving 90 degrees. This is free-handed, so you understand that it's not bad for three-handed. Am I getting this right?
Yep.
Okay, right.
Beautiful.
Wait.
Cassius, would you like to add?
Negative. Huh?
It's negative charge.
So negative negative.
Yeah, that's right. Why?
Because it turns to negative.
No.
Because it's the direction of positive.
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 Point charge
Thingy.
thing.
No, not a point charge.
Corona charge.
Positive charge.
Starts with letter T.
Positive test charge.
Positive test charge.
Test charge.
Daniel, define a positive test charge for me, please.
Test charge.
It's the way.
I'll leave that one. Let's do it.
No, Cassius.
I don't know.
Elizabeth.
Answer.
Positive test charge. What's a positive test charge?
Positive test charge is when the arrow is facing the other way, right?
Okay, so we need to have a method by which we can define the direction of an electric field, right? So unless you've got a point of view, just like an inertial frame of reference, you cannot define the direction of the electric field. Therefore, we postulate a made-up particle, which is what we call the positive test charge. A positive test charge is an infinitesimally small positive charge, so small that it makes absolutely no impact on the electric field that exists. Because of course, if you bring another charge within the location of this one here, be it negative, they will push away. If it's positive, then they'll attract. So if you put a positive test charge in there, well, you're going to get that whole attraction thing going on. But it's so small that it makes no impact on the field. I like all your green, that's great, Liz, thank you. Hopefully it comes through on the camera. It makes me sound like I'm interesting and know what I'm talking about. You put a positive charge there, it's going to impact on the field. So we make it so damn small that it's not, but we know which way it's going to go. So you look at it and you go, well, which way is a positive test charge going to go? If this is a positive charge, well, it's going to want to go away. So that's the direction of the field lines.
What? If that's a positive charge, will be attracted?
No,
But it repels from
No, but it pulls
away.
Like it's going out and
Now-
it's negative goes
Yeah,
in.
no way.
Sucks.
As you can see, an electric field has an impact on a charged particle. Yeah?
Yeah.
Right. So you would have seen the whole concept of the ridiculous infinite plates. One plate, another plate. Let's say for this one's positive, this one's negative. And they have a uniform charge. We draw the field lines, and you will be expected to do this either in the exam or in the test that I give. The line should always leave and arrive at 90 degrees. I haven't drawn them all, they should go to the lines, right? Okay, now you get to add arrows to it. Up or down?
Oh.
Oh.
Up.
So can you do the end pieces because that confuses me.
I'm going to do them and then I'm going to rub them out.
It's like a Tesla coil.
Right.
So,
You see,
Looks like a fat pumpkin, if I'm being honest.
that's how it goes. But when we are dealing with any questions to do with this kind of arrangement, we forget about them. Because when you've got the thing that launches the electrons in, the electron gun like finishes right there. So the curvy bits don't matter.
On both sides?
On both sides. Just like when we say there's no air resistance involved, other than your practical where it is, we forget about those bits. It's like saying I have an infinite plate with a hole. There's your infinite plate. It's got a hole in it. Anyway,
it's 2 plates.
your face is 2 plates.
And that's all it takes.
Yeah.
Okay, no.
Are you inflamed today?
Yeah.
First was my ears.
I'm the insult master. Alright. If you got an electric field, so we've got 2 plates of that, and we make this one positive and that one negative, and between them you say, for example, apply 3,000 volts.
Go for it.
Got him.
If
No,
you
no.
like the
So why is it going from negative?
No, you were 3,000 volts.
You are what you
Oh,
say
No,
what you are.
when you, no, you was like the last one. If you say you're 3,000 volts and then you say back to me, no, you're 3,000 volts, you're the winner. That's it. There's no further responses. This has
know
been
you are.
determined by
I know you are
scientific
one of mine.
research.
I know you
No,
are one
that's,
of mine.
that's primary school bullshit. Alright, so we've got an electron, right? It's here. Its initial speed is stationary. No one say anything that it's not, because it is, because that's the way it is, alright? Now what's it going to do?
It's gonna attract the
Yeah, it's going to go across. It's going to go directly across, that way. Now it's going to go across at a constant speed.
No.
No.
No, because it's got a force applied to it, doesn't it?
Which is
Yes.
acceleration.
No, acceleration.
It's going to accelerate, yeah. Why? Because F equals ma. Alright?
It's actually
So, when the electron arrives at the other side, how much energy does it have?
3,000 electrons.
Yeah, good man.
How much what does it have?
3,000 electron volts of energy.
Isn't an electron volt of energy?
electron
It's volts
and times it by
The charge on like.
Yeah,
It's
new conversion. 1 electron volt is equal to 1.6 by 10 to the negative 19 joules.
Clearly.
You see, when you're dealing with electrons, they're very small. So when you want to talk about energy of electrons, you need something that facilitates the very small nature of them. So that we can talk about their energy in more understandable terms, such as the thought process anyway. And that is why the electron volt exists, more or less. So it's going to arrive with 3,000 electron volts of energy. Great. How many joules is that?
3,000 times 1.6 times 1.90.
Mm-hmm. 3,000 times 1.6 by 10 to the negative 19 equals that many joules.
you get that? Huh?
No, because the charge of 1 is what you just said, and you just times that by that.
Yeah.
Oh,
I'm going to need a calculator.
calculator.
You see, I didn't need no calculator until all of you rocked up. Oh, my name's an Essington student. I'm motivated. 3,000.
sorry.
Actually, no, that is a really good thing. I'm just joking.
CSC, you know?
Because other schools got like really low attendance times 1.6 by 10 to the power of negative 19. Go across the bracket. Okay, so 4.8 by 10 to the negative 16 joules.
Yes.
What speed is the electron doing when it arrives at the other side?
E equals mv squared over 2 rearrange that.
Huh?
E equals mv squared over 2.
Oh, why don't you,
Or do you want to use something else?
I'd probably be moving towards that one. Is that the one you were talking about?
Yeah.
Yeah, okay, yeah. Kinetic energy formula. EK equals half mv squared. You want to solve for V, you rearrange. V is going to equal EK times 2 on m and all square root.
Yes.
You need to be able to rearrange that to get V out of it. So the velocity will equal square root of 2 times 4.8 by 10 to the negative 16 on 9.11 by 10 to the negative 31. Remembering that the mass of an electron can be gotten simply by looking at the formula sheet. It's one of the things you receive. So 2 by answer divide 9.11 by 10 to the power of negative 31. Second, where does the square root of above square?
second, and then it's like,
Yeah, I got it. Alright, so it's going to equal 3246208.6.3 meters per second.
That does not seem legit, but
Yeah, but it's an
No.
electron gases.
I don't know.
Think about how small it is.
It's massive.
So that's
very, very fast.
It's pretty fast, so
It's like speed of light.
So where's half
that's
1, 2, 3, 4, 5, 6, 7. So it's an order of magnitude up the speed of light. So it's not the speed of light.
Yeah.
What about half mv squared?
Okay.
It's on the motion
So-
relativity formula.
The electron is fired into this electric field.
Okay, that's
Okay?
insane.
It arrives with that speed. Now, what's going to happen to the electron? That's its horizontal speed, right?
It goes sort of like
So
a
it
parabolic
curves to the
path
bottom.
towards the positive.
Towards the positive. So it's going to be attracted to the positive and repelled from the negative, and so its path is going to look like that.
Yeah.
Twitch is strict.
Now the thing is, you can't work this shit out unless you've got a length of the plates. Of course, the longer the plates are, the more time there's a force applied by the electric field. Right? So let's choose 15 centimetre plates. It's often written in centimetres, and of course when you're dealing with this kind of stuff, you'll need to convert it to metres, yeah. So, what's the time of flight through the plates? Speed is equal to distance over time, therefore time is equal to distance
Speed divided by distance.
speed.
Yeah, distance by speed.
Now remembering that this is done in a vacuum. There's nothing to get in the way of the electron going through those plates.
Nobody's gonna do it.
So distance will equal, time will equal,
It's a vacuum, Cassius.
What'd you say, bro?
It's a vacuum.
Oh.
Huh?
That's what it is.
point 1,5 divide second and. So the time of being between the plates is 4.62077597 by 10 to the negative 9. Give your answer in picometers, picoseconds, correct the three significant figures, please.
I would rather.
Jared loves that one.
Yeah.
Yes, it's not.
Things getting better.
It's not.
Actually, no, not pico, nanoseconds.
Jared's in your memory, right?
Yes, he is.
All I can see is that man's head.
I don't think I've seen Jared for about a year. Picoseconds. So time is equal to 4.62 nanoseconds, nanoseconds, because nano is by 10 to the negative 9.
Newton seconds.
It's a small n, Cassius. It's a big n.
It's a joke, sir. It's a joke. All units are big. Right? Meters per second.
Okay. How far is it being deflected? Well, to work this out, we need to have an idea of the amount of force it's going to be experiencing.
Yeah, that'd be helpful.
If you pull the plates further away, then the effect is lessened. The closer they are, the more intense the force is going to be.
E equals 1 over 4
you'll
pi
only get
epsilon QR squared.
Figure like 10 centimetres is between the plates, right? So, what's the formula for working out the electric field between the plates?
F equals no.
No.
F no. E equals no. E equals
Good boy. E equals delta V on D.
Hey.
Yeah, that's the one I was thinking of. Not
Yeah, yeah,
the other
same,
one
same.
at all. 100%. I was just about to say that.
Now, of course, we're not going to know or still be able to answer this without then getting a delta V. So let's put another 3,000 volts across it. And 10 centimetres.
But isn't V, that V is volts, not velocity.
Now, you've got to be very, very careful here, because when you receive a question like this, you're going to get two sets of volts. You're going to get the volts that the electron was initially accelerated through before it goes into the field. You're also going to get a volts which is applied across the plates. And if they're different, you don't want to mix them up, especially if it's in a written word question. If it's not given to you with some kind of picture, but it's written into the question, you're going to have two sets of volts in the same damn sentence. Watch out. It's like when you're doing them questions related to projectile motion, and you've got three velocities available to you. You've got the full-blown velocity and its components, horizontal and vertical. And you can start feeding in the wrong velocities into the formulas. It's like any computer, rubbish in, rubbish out. You know, you're not going to get the right answer if you don't use the right figures. So please try and be very clear, and because the maths is not difficult, it's really easy. The difficulty is all the garbage that's written into the question, including sometimes information that's not relevant. Alright. So what's 3,000 divided by 0.1?
30,000.
So easy.
Alright. Is that your final answer?
No.
Yes.
Huh? Volts.
Volts per?
distance.
Volts per distance, volts per meters. Alright, now here's the deal. 1 volt per meter is equal to 1 Newton per Coulomb. You might be aware of newtons per Coulomb from the electric force calculation. Now we're going to do volts per meter.
Wow.
See?
Where we don't do volts per meter.
Okay, now we're going to have an acceleration applied to it. E equals delta V on D. So we've got the electric field strength.
30,000 volts per meters.
Which is the same as 30,000 newtons per Coulomb.
Yes, but we want it in volts per meter now. I was just putting this up so you understand that there's a equivalency there.
1 to 1.
30,000 volts per meter is applied between these two plates. But we need to find out what the force is.
Well, if you know.
E equals F on Q. E equals F on Q. E equals F on Q. All of this is available on your formula sheet. Therefore, what's the force going to be? F equals
QE.
EQ.
Okay.
I don't know, it can be QE, that's fine, but I'm used to writing EQ, so that's what I do. Alright, F equals EQ. So what's the force on the electron going to be?
30,000.
30,000.
F equals 30,000.
And the charge of an electron,
1.6 by 10 to the negative 19.
which is carry the one.
Jack.
Got it. Locked in, seeing if you get
So
it
it's
wrong.
going to be like 2 million something. 2 million for
31,000 something.
Okay.
It'll be way more than that. Is it times or divide? I don't know. It's
Think
times
about
divide. It's
it.
gonna
Like
be
you've got a
small.
negative 19 number times by
Dang, it's
30,000. It's going to be
I
really
love
small.
divide, I'm sorry.
4.8 by 10 to the negative 15 newtons.
Oh, so close.
And which way is it?
To the top, bottom.
To the
To
bottom.
the bottom.
Down.
Downwards, so it's a positive charge.
Now we
It's
can
a
figure
negative
out.
Negative
It's a
charge.
negative charge.
Okay, guys, okay.
Okay,
Maybe the third time.
Alright,
Stop it, Mom.
what then is the vertical displacement? Yep.
It would be.
Which formula are you going to use from there?
S equals.
Yeah, good man. We're back here. We're back to this shit again.
Oh.
Yeah, there it is.
Using that one.
Yeah, it's coming back. All of the
But we
projectile
don't
motion
see.
comes back.
Oh,
S equals V0t plus a half AT squared. What's the initial horizontal velocity of the electron when it's in there?
0.
Cut. So S is equal to half
Vertical,
AT
sir?
squared.
You mean vertical?
Yeah,
Right,
horizontal, you have.
Sorry, initial vertical, yeah. So we cut that. We know the time of flight because we worked it out somewhere.
Yeah, 2.4.
This one, this is the time of flight here. That's the time it's going to take to cross the plates.
Yes.
So we got T. Do we have A?
No,
Yeah,
we don't.
How do you get it?
F equals QE and then F in the MA.
Yep, F equals MA. Therefore, A is equal to
QE over M.
F on M. I mean, you can combine them all like that if you want, Cassius. It's up to you. But I like to do it step by step, personally.
It's on the
So
formula.
A is
Yeah,
equal
why-
to
It's on the formula sheet, so.
yes. Oh, is it?
A equals.
Well, I'm just kind of pulling this out of my butt, so you know, because all of you rocked up. So force
Sorry.
divide 9.11 by 10 to the power of negative 31.
I'll call police on you.
5.26 by 10. So the acceleration is 5.26 by 10 to the 15 meters per second.
Square, no.
Yeah, that's.
So-
Oh, yeah, it's acceleration.
You go look here. From one moment, we're going from a real small amount of time, bugger all joules, a really small force, and a really massive acceleration. So these numbers are like small, big, you know.
Because it's small, it's big.
Yeah, well, it just depends on what you're looking at. So that's a huge acceleration, right? But it's applied over a very short period of time.
Because only 15 centimeters.
So if we take that and we put it into x equals half AT squared, the displacement in vertical will equal 1 over 2 by 5.26 by 10 to the negative 15 by, and you're going to get this time and you're going to square it. 4.62.
Isn't it
Look.
positive 15, sir?
Yeah, so the time is.
Sorry.
Thank you, Daniel.
Acceleration.
Because you just said it was really.
Yeah. No, you're right. You're absolutely right. So that's
He gets a lolly now.
by foot. Well, he can help himself.
Times 10
And
to the
then-
power negative 9 and then square it.
4.62. Look, I want you to leave all these all the decimal points in, right? But I'm just going to cut it off to save time by 10 to the negative 9 squared. So you need to leave all them decimal points in when you do it.
In total.
So 0.5 times that equals.
Why?
Watch it be more than 10
Times.
centimeters.
Yeah, it's gonna. You're gonna whack into the.
I don't know. It might do. I'm going to find out in a second because these are all made up figures.
It
So
doesn't have to be more than 5 centimeters if it ends at the bottom. At the middle.
yeah. You're right.
You can find the sign from the.
So have we established that it's sped up?
Okay. So the displacement in the vertical direction is 0.0562 meters. And if we turn that into centimeters,
That's
5.62 centimeters.
So
Now if these are 10 centimeters apart, and this is a perfect example, like I'll engineer the problem before it goes in, but you're going to find that the electron's going to hit the plates.
And then the whole thing just explodes.
Yeah, there's
No, it just hits the plate. Who cares?
It doesn't
Right,
bounce
here's
or
what I want you to do. Work out how far along it got. Go.
Oh.
I can't find
Yeah.
it or.
Yeah? Work out how far along it got. Get off the puzzle, get off your asses, drink your gross, whatever that is. Do it.
King
Do it.
monster.
It's actually juice.
You rocked up here, you do it now.
What we calculate?
Work out, because it goes, what we've calculated is if it was given the time to go through the plates, it would go 0.562 meters. It's going to go 5.62 centimeters, but here's the problem. It's entered the plates halfway. There's only 5 centimeters between here and here. So, if it's going to go 5.62, well, it's going to end up crashing into the plate. Not only do I want to know how far it got along the plates, but I want to know at what time it crashed into.
What time?
How long does it get to travel in the plate before it crashes
This
in?
is projectile motion, right?
And calculate its precise velocity the moment before it crashes. Magnitude and duration.
Right, so does the electron speed up when it enters the thing? Is that what we
It
worked
speeds
out?
up in the vertical direction.
Yeah.
Oh,
Bar horizontal stays the same.
so what's
Just
that at
like
the
a
bottom?
projectile motion.
What's the energy kinetic equals? Is that just for a different...
That's for.
This is how much it ended into the field with, because it's accelerated across 3,000 volts.
Ah.
It enters with that many joules, and by working this out, we can then get the speed at which it enters.
And the horizontal speed will stay constant.
Yes, always does. Air resistance is not included. Yep. Well, actually, it's quite easy to do with an electron, of course, but you just put it in a glass tube and suck out the air. That's simple.
That'll get its distance, right?
Much more easier than like a ball is thrown in no air.
Wait,
Well,
so
we
what's
already
it
have the
lands
time.
right here?
No, it lands here.
We
It
have
doesn't get that far.
so it's just B equals S on T.